Questions are on our fair game. So you do not have to ask him a clarification that is within the scope, or a question, general knowledge question, that is within the scope of his study. If you are curious about something and he's not discussed it, you can ask him. However, let's keep in mind that this is Ebola, right? And so there's a lot of information in the news right now. So just be careful when you are asking questions. Make sure you're listening to the entire answer, right? So don't just like hear the first word and then stop listening and then go outside and say, oh, you know, Ebola is a pingreed. We have to be careful with this one because of its
sensitive nature.
Controversy? Yes, thank you. Because of its controversy. Mm-hmm. So let's give Mark Shtrackham a big hand. You're up, buddy.
Okay, so the name of my paper was Reversion of Advanced Ebola Virus Disease in Non-Human Primates with ZMapp. That's kind of a mouthful. In simpler terms, it's complete reversal of Ebola symptoms in monkeys using ZMapp. And we're going to be talking today about what exactly ZMapp is, how it works, and how we got to what we now know today as ZMapp. So first off, just a couple of acknowledgments. It takes a lot of work to get this running every Thursday. Sydney, Claire, Andrew, Mr. D, Jackson, Amanda, all these people work so hard to do this. And also, it's Andrew and Jackson's last week on Journal Club, which is really sad. I mean, not really, but
Andrew Jackson.
Andrew Jackson, the president. Yeah. And so, just like, thank you to them for all the hard work they put in over the last year and so. And yeah. So we're gonna clear some things up today. Back in August, CNN ran this story of secret serum given to U.S. Ebola patients, and nobody said what the secret serum was for a few days. They only said what it was a few days afterwards, and it later turned out to be ZMapp. Also, Mr. D this morning tweeted what, not going to say what that is Ebola. I thought that meant grandma in Spanish. That's actually Abuela, and Mr. D didn't do well in high school Spanish. You hate to see it. So, first off, let's talk about how bad could it theoretically be. This is a CDC model of the current outbreak of Ebola. As of last week, there have been over 10,000 confirmed cases, 5,600 have been confirmed in a lab, and 4,900 people have died from that. That gives you a mortality rate of about 48.5%. And that's what the big scare from Ebola is. This is a model of how bad it could be. The red line represents where we are to date, and everything past that is theoretical. Here it says, you can see here that the line kind of starts to break up into 3 different lines, and that's based off when the CDC suspects there could be an intervention. Intervention is what the CDC defined as a treatment that works and is widely available. So even if you started with it, say you got an intervention a month ago in September, it wouldn't be widely spread until about December, and that's when the number of Ebola cases per day will start to drop. And as you can see, the later you get an intervention, the worse the situation is going to be, and that makes sense. So first off, we need to talk about what the difference between a virus and a bacteria is. Bacteria are these little single-celled microorganisms. When you have a bacterial infection, you're given antibiotics as a treatment. If it's something like strep throat, you get amoxicillin or another type of cell. Viruses, on the other hand, require a living host to multiply. You can't be given antibiotics for a virus. You can, however, be vaccinated against a virus. Yeah.
What about antivirals?
Antivirals treat viruses, but they're not the same as antibiotics. Antibiotics actually kill the bacteria. Yeah? No?
Questions? This is the time for questions. Early in the presentation. You want to ask questions right now?
Yeah, you're allowed to ask questions. Go ahead. Yeah, the flu is a virus.
So why can't we treat Ebola with antivirals?
We do. You'll see in a few minutes that ZMapp is actually a combination of antivirals. So what exactly are Ebola's symptoms? It causes hemorrhagic fever, it causes bleeding, that's what it means. And nobody actually ever talks about how Ebola kills someone, because they just say Ebola kills someone. Bleeding ultimately leads to organ failure. There's just not enough blood pumping in your system to power all your organs. It had an incubation period of 3 to 21 days. That means symptoms between the time you were exposed to Ebola and the time you show symptoms is 3 to 21 days. And that's why you might have heard like people are being quarantined for 3 weeks. That's where the number comes from. And this is, yeah?
What would account for someone experiencing symptoms, let's say, within the 3 to 5 days versus the 21 days?
Cassie Yermak, please come to the middle school office. Cassie Yermak, please come to the middle school office. Thank you.
It has to do with individual genetic factors. Like everyone has their own immune system, and some people get sicker from something, some people get sicker quicker, and that's how the 3 to 21 day period arises. Yeah. And this is important. You're only contagious when you're symptomatic, and that's according to the WHO, which is a very distinguished medical body, and the World Health Organization. You all, yeah.
Are there specific parts of the body where the bleeding occurs, or just?
It's mostly internal bleeding, but also we'll talk about the symptoms in a second. But it includes bleeding from the eyes, nose, and mouth. Yeah, charming. I know. You're old. Yeah.
Now this, the bleeding counts as like the bodily fluids, right?
Yeah.
Yeah.
It's only spread through bodily fluids, and that's an important idea that we'll talk about throughout the presentation. But also, you're only contagious when you're symptomatic, but more specifically, when you're only like red symptomatic, when you have the red, symptoms like vomiting, diarrhea, impaired liver and kidney function, things like that. Yeah. Any question? No. Okay.
What's the CDC?
Center for Disease Control and Prevention. They're in Atlanta. Yeah. They're like American doctors. Good way to put it. So first off, the researchers wanted to test a bunch of different combinations of antibodies to treat ZMapp. The groups of monkeys were infected with Ebola K or Ebola Kikwit, and we'll talk about more about that later. Group A was given something called ZMapp1, which was a combination of 3 antibodies. Group B was given ZMapp2, which was a combination of 3 different antibodies. And Group C was given a control, which was saline and some general like viral antibody, things that they used to treat like regular, more common viruses. All of the monkeys in Group C, the orange line, died within about 8 days. None of them survived to the end of the study. About 80% of the monkeys in Group B survived to the end when they were given ZMapp2. Every single monkey given ZMapp1 survived to the end of the study. And that's great. I mean, that's important here. Yeah.
How many monkeys were there?
These were done in groups of 12 monkeys. Yeah.
How do they obtain the antibodies?
These antibodies? They just, they decide, I don't know. They decided, I don't know.
Do they keep track of any of the results long term? Because I mean, 30 days isn't really all that much in a long term scale. Do they survive like after the study was over? Are they keeping track of their survival?
They didn't say if they kept track of the monkeys to the end, but they did measure if the virus was still in them at the end of the study, and they found that it wasn't. We'll talk about that in a sec. So that's how they could say that they all survived. Yeah.
Does the Ebola virus mutate quickly?
I don't know. I really don't, but I can tell you that the current strand of Ebola has been the same for the last couple months, and it's known as Ebola Guinea. And yeah.
Then why several different antibodies in ZMapp?
Why? So one antibody just hasn't been shown to be an effective treatment. 3 antibodies was shown to work. Yeah. Yeah. Sorry.
How would 2 different antibodies work differently?
Honestly, I don't know enough about viruses to tell you that.
I think, okay, so antibodies target different parts of viruses. So if a certain virus had maybe one part that was mutated, the other 2 targets, so that part, the shape would be changed, theoretically. But the other 2 targets might be the same. So you're basically just a virus that would avoid those 3 antibody cocktail would have to have 3 different mutations in those 3 places, causing 3 different shape changes, which is highly unlikely. Well, just more unlikely.
Yeah.
Could it be possible to get all 6 at once?
I mean, theoretically, you could give someone all 6 antibodies at once, but there's no, like, could that work? I have no idea. Yeah. Anyone? Yeah.
Can you talk about side effects of having these 3 antibodies injected into a monkey, like group A that had no deaths? Were there any like serious side effects?
There weren't any serious side effects, but they still were experiencing symptoms of the disease.
Okay.
So they were still infected with Ebola. Yes. Yeah. Any other? Okay. Okay. So then after that, wait, let's go back a second. Here you can see ZMapp1 is clearly a better treatment than ZMapp2. 80% is good, but 100% is even better. So from this point on, the researchers dropped the name ZMapp1. It's just ZMapp. ZMapp2 will never be brought up again. No. Yeah. And now they want to test the window of treatment. How soon after being exposed to Ebola do you need to receive medicine in order for it to work, in order for it to treat you? And the monkeys were divided into 4 groups. Each group had 6 monkeys. And on day 0, they were given an injection of Ebola, enough Ebola to, without a doubt, infect them. They were then separated into groups D, E, F, and G. Group D received injection of ZMapp 3, 6, and 9 days post-infection. That's what DPI means. Group E received ZMapp 4, 7, and 10 days. Group F received it 5, 8, and 11 days after being exposed. And then Group G, which still got saline and general antibodies, they received it 4, 7, and 10 days afterwards. Yeah. And this is just a timeline for it to be easier to see, but you can see this pattern. And also, these black arrows just represent the day they checked on the monkeys for certain specific symptoms and like blood cell counts and things like that. Yeah. Any questions? So here we have the same key, and we have the same group of monkeys, except now we're going to see if they survive. Within 8 days, all of the monkeys in group G had died. Yeah. Except all of the monkeys who were given ZMapp survived, regardless of when they received it, 3, 4, 5, starting 3, 4, or 5 days in. And in case you're wondering, they laid it out like this just because they wanted to show all of the monkeys survived. It's not like one monkey in the green group sort of like died while the other 99 survived. That's just, they had layout issues and overlap 3 bars. Yeah. Yeah.
So, but you see the first group of monkeys dying in the C group after like 4 days, right?
Yeah.
So how did all of the ones in the Z group survive 5 days?
Not how they survived like that far.
In the F group.
Yeah. Yeah.
No, I know. So some of the control monkeys started dying after 4 days.
Yeah.
So how did group E and F survive those 5 days without treatment?
Honestly, the researcher didn't go into that. But, yeah, they didn't go into that, but we'll see in a second the clinical scores.
How many?
6.
So that constitutes
Yeah.
2 monkeys.
What?
Basically, right?
Yeah.
So that drop constitutes 2 monkeys?
12 monkeys.
6.
Drop
6.
like
6. The first card had 12.
Oh.
Does everybody understand what he's talking about?
Yeah, that's a great question. Yeah.
So let's just to clarify. If you look right there, can you point to the black line? So 2 monkeys died there, right? But they hadn't received, and that was a control group. They were not going to receive any vaccine. However, what that one kid just pointed out is that the group Z, the green group, at that same point, Mark.
Yep.
At that same point, still hadn't received any therapy. So 2 monkeys from the control group died without receiving therapy. The group F had not received therapy, and no monkeys died, and he's trying to figure out why. Great question.
Treatment on day 0.
No. they were just exposed on day 0. Yeah.
This is more of an informational question, but when do monkeys start to become symptomatic?
All of the monkeys here were symptomatic starting on day 3, and the first symptoms they experienced were fevers. Yeah. Okay, so we're still looking at the same group of monkeys, and we're going to see how the treatment date affected the monkeys. Yeah. We still have the same key, the same monkeys, and just so you know, these are the same, this is the same graph except twice. I just put this one here because you can't really see the blue group like behind here. So it's the exact same thing. And this is a measure of clinical score, which measures disease progression and like just how sick patients are in a study. And in case anybody's wondering, this dashed line at the top, there's a group that regulates animals in scientific studies, and if an animal in any study ever crosses that black line, you're legally required to euthanize it. None of the monkeys actually went past that black line, but you can see that the 2 black monkeys died right before hitting that black line, and the orange group monkeys got dangerously close. And as you can see here, the clinical score for the first group, Group D, remained pretty low the whole time. Never really went higher than that. All of the monkeys in the end survived in that group. In Group E, you can see that the clinical score spiked, particularly just about like after they received treatment. And you think, why is Group E higher than Group F? After all, Group F only got the medicine a day later and they're somehow sicker. This is because the researchers suspect that there's some genetic component to your susceptibility to Ebola. And that makes sense. It's going back to the idea of your immune system. Every immune system responds differently. And since we only have 6 monkeys in this group, 1 monkey is going to shoot this line like very high. Yeah. Yeah.
How do you measure clinical score?
Clinical score is different for every single disease. And they didn't talk about it specifically in the methods, but it's based off of like symptoms of the disease, like what symptoms the monkey in this case is experiencing, and like how far it is like along the infection. So they were all exposed on day 0. Okay, so this is one last like really important thing. All the testing in this study was done against the Ebola Kikwit strain. Except the problem is, Ebola Kikwit isn't what's responsible for the 10,000 cases of Ebola out in the world today. That's the Ebola Guinea strand. And the researcher didn't say why they couldn't get Ebola Guinea. Maybe it was sold out at their local medical store. I really don't know. But at the end, they were able to get a little bit. Maybe borrowed it. And they measured each antibody's ability to bind to the new strand. And I know this looks really confusing, but all you have to see, this purple line represents Ebola Guinea, and this black line represents Ebola Kikwit. The purple line is always, throughout all of this, is higher than the black line. And this is for one antibody, but all of the antibody graphs look the same, and I can show you at the end if you want. This means that it's actually, theoretically at least, it should bind better to Ebola Guinea and be a more effective treatment against Ebola Guinea than Ebola Kikwit. And that's actually really, really good news. And yeah. So, you know, like now what? Why is this important? Well, obviously, the big thing is there's hope for conquering the current epidemic of Ebola. In primates and to people, these guys, ZMapp has proven to be a successful treatment. But there's more work needed to be done. You know, this isn't a vaccine. If I gave you ZMapp today, there's no guarantee you couldn't be infected with Ebola if exposed. There's also this idea, can someone be like reinfected? The thing about it like this, you get chickenpox once in your life, you're never going to get chickenpox again. On the other hand, you get strep throat, people get strep throat every year, get antibiotics for strep throat every year, and they still get it every year. And nobody knows if you could get Ebola twice. It just hasn't happened yet, and no one really knows. And yeah.
And what is the difference between strep throat and chickenpox?
Chickenpox is a virus. Strep throat is bacterial infection. That's why you get antibiotics. Yeah.
So if it's a virus, how could you be reinfected with Ebola?
How could give you like a scenario where you could, a medical worker who like got Ebola from treating patients with Ebola. and then re-got Ebola.
Virus.
What?
He's asking about viruses.
Yeah, about.
Like, how could you be reinfected? You could be re-exposed.
What if you already have the antibodies?
Yeah, he's saying if it's a
Yeah, but nobody knows that that's gonna stop you from getting it again. What? Yeah, that,
I'm confused by the question.
he's saying like if you already had the antibodies, how could you possibly get it again?
I mean,
No one knows.
yeah, there are viruses that can get the virus.
Yeah, there are viruses. You can get the flu every year.
Like, yeah,
Well, yeah, but that's a different flu.
but like,
Yeah, but
you
you
feel like
still
it
can get it
has
every
it
year.
twice, I'm pretty sure. Bacteria.
So maybe it's the same
I think the answer to that one is we don't know the specific mechanism of the body's defense against these viruses yet.
Yeah, that's Ebola for you. Yeah.
It looks like this data is pretty strong when it comes to actually proving it can reverse the virus, but those two factors on the graph at the beginning were like can actually be distributed. And I know that's kind of like a public health question, but do you know if there are like issues with that?
What, with this?
Yeah, like if it would be ridiculously expensive or something like
The
that.
current problem is ZMapp is grown in a modified tobacco plant. Because, I mean, it just is. I don't know why it's grown in a tobacco plant, but that's the current problem with getting ZMapp. It needs to actually grow through a full tobacco plant, which takes time. Yeah.
So for like the Ebola patients that were able to survive the
Yeah.
Ebola, did they use ZMapp as one of the cures? Or
Yeah.
was
The two doctors who worked with Doctors Without Borders in Africa and were flown back to Emory back in August, they were the only two people to have confirmed received ZMapp, and it worked for both of them.
So like the one guy that passed away from Ebola, did they use ZMapp on it? Because
They didn't say, and I have no idea. They never released that they used ZMapp on him. Okay, yeah.
Are they going to start using ZMapp now as a normal treatment for people?
The problem, there's a need for more studies in humans. They kind of jumped the gun on this because they had monkey studies and then they gave it to these two doctors. And normally with any medication, it has to go through a lengthy human trial phase. Yeah. Anybody else have questions? Yeah.
Ebola, your last chance to ask questions about Ebola.
Hopefully you never have to ask questions about Ebola.
Okay.
Do you know why the researchers use monkeys instead of another animal to test them?
They use monkeys because of their similar immune systems and it's easy to see the symptoms in monkeys. Yeah.
Out of curiosity, is anybody going to avoid New York?
Next week, Sydney presenting on obesity.